Let us discuss carbonyl compounds. In the carbonyl compounds, we will take alpha beta unsaturated compound. We are taking alpha beta unsaturated compound. Alpha beta unsaturated compound reacting with the Grignard reagent, that we will take. Alpha beta unsaturated compound reacting with the Grignard reagent, that we are taking. Okay. Now we will take a alpha beta unsaturated compound. Here pi bond is present, here pi bond is present, here O, here some R group present, here some R group present. Okay. This is a carbonyl group. This carbon is directly attached to carbonyl carbon, therefore it is alpha carbon, it is beta carbon. So between alpha carbon and beta carbon, pi bond is there, therefore it is called alpha beta unsaturated compound, we can say. This alpha beta unsaturated compound, we can say. Now we will take Grignard reagent. Grignard reagent will take. Okay, this alpha beta unsaturated compound is reacting with the Grignard reagent, that we'll see. Okay. Now what happens means this bond is migrating to this place. It is attacking this carbon. This pi bond is migrating to O. This O is attacking this Mg. Therefore, we will get here R, here double bond, here R dash up is there, R2 dash newly comes, then OMgX, OMgX. Okay. This is the product. This is the addiction product. Addict. It is called adduct. We will call this as adduct. Adduct we are getting. Then it is taken for hydrolysis in the presence of acid. It is taken for hydrolysis in the presence of acid. It is taken for hydrolysis in the presence of acid. Okay. Now how the hydrolysis takes place, we will see. Here this bond is breaking. Here H plus, here OH minus. Therefore, we are getting a what is a product in the sense we are getting like this product. Here R will be there, here pi bond, here R dash, here R2 dash, this O becomes OH. This magnesium leaves as a halo hydroxy. Okay. Magnesium compound is leaving as what in the sense MgXOH. MgXOH. Okay. So we got like this product. Now we will see the reactant and we will see the product. Reactant is what in the sense this is a reactant. At this carbon, one R group is added, R2 dash is added. This at this oxygen, hydrogen is added. Therefore, it is called a addition reaction. This addition reaction takes place at this place and at this place. Therefore, we will call this as a 1,2 addition. We will call this as a 1,2 addition. We will call. Okay. So we said here 1,2 addition reaction. We said okay. Next we will take. Next, we are taking same alpha beta unsaturated carbonyl compound. We will take alpha beta unsaturated carbonyl compound. We are taking. Sir. Now, this we will treat with the Grignard reagent. We are treating this with the Grignard reagent. Ether is a solvent and slightly warmed. Here also solvent is ether and slightly warmed. Okay. So what is a product that we'll see? What is a product we are getting? That point we'll see. Okay. Now this bond is shifting like this. This bond is shifting like this. This R2 dash is attacking here. This bond is shifting here. This bond is shifting here. This O is attacking this Mg. Okay. So this bond is shifting to R2 dash. R2 dash is attacking this carbon. This pi bond is shifting to this place. This pi bond is shifting to O. This O is attacking this Mg. So what we will get now that we will see. Here R will be there. Here what comes in the sense R2 dash. Here what comes in what will be there in the R dash. Here pi bond is newly produced. Pi bond is newly produced. Here O MgX comes. MgX comes. Okay. This O is making bond with the Mg. This O is making bond with the Mg, we can say. Then hydrolysis in the presence of acid. Hydrolysis in the presence of acid. Now we will go for hydrolysis. This side H plus, this side OH minus. Okay. So what we will get, we will see here R, here R2 dash, here R dash, here pi bond, here OH. Like this we will get. Then we can say it is going for tautomerism. This is going for tautomerism because double bond and OH group are in conjugation. Therefore, tautomerism is possible. In the tautomerism, this bond is shifting to this place. This bond is shifting to this place. This H plus is going to this place. Okay. Therefore, what is the product we are getting? We'll see. Now, here R group will be there. In this place, R2 dash will be there. In this place, R dash will be there. This double bond becomes single bond. Here single bond becomes a double bond. Here O will be there, H will not be there. H has gone to this place. So on the product we are getting. Sir, this is a, this reaction is what that we'll see. This reaction is what that we'll see. Now, at this carbon, what is added in the sense R2 dash is added. At this carbon, R2 dash is added. Then at this oxygen, hydrogen is added. Therefore, it is addition reaction. So we can call this as a addition reaction. We can call, sir. In the previous case also we said addition reaction. We said now also we are saying addition reaction. In both cases, if you see, reactant is same, reagent also same, but product if you see, in this case, in the above case, product is alcohol. In the below case, the product is ketone. And also R2 dash at this carbon, R2 dash at this carbon. Here CC double bond is present, here CC double bond not present. Instead of that, it is ketone. Here product is ketone, but here product is alcohol. So product is entirely different. This product and this product entirely different. Though reactant and reagent are same, product is entirely different. Sir, this we said as 1:2 addition. Why? Because at this oxygen becomes OH. That means at this oxygen hydrogen is added. This carbon, at this carbon R2 dash is added. R2 dash is added. Therefore, at first this carbon, this oxygen, this carbon neighbors. Therefore, 1:2 addition we said. Now we will see here. In this case, at this carbon, what is added means R2 dash is added. At this carbon, R2 dash is added. At this oxygen, hydrogen is added. This first, this is number 1. This is number 2. It is number 3. It is number 4. Therefore, it is called 1:4 addition. We can say 1:4 addition in the sense oxygen is number 1, carbon is number 2, this carbon is number 3, this carbon is number 4. At this fourth atom, R2 dash is added. Therefore, we are saying it is a 1:4 addition. So, this alpha beta unsaturated compound. Alpha beta unsaturated compound undergoing reaction with the Grignard reagent in the sense 2 addition reactions possible. One is 1:2 addition, another one is 1:4 addition. So we'll get a 1:2 addition product and 1:4 addition product we will get when alpha beta unsaturated carbonyl compound goes for addition reaction. So next we'll take alpha beta unsaturated compound. One example we will take. What is the example we are taking in the sense the substance is so and so. This is called what in the sense acrolein. This acrolein, otherwise it is called acryl aldehyde. It is called acryl aldehyde, we can say. It is acrolein, we can say, otherwise acryl aldehyde. Acrolein, otherwise acryl aldehyde, we can say. With Grignard reagent, phenyl magnesium bromide, Grignard reagent, phenyl magnesium bromide. Ether is the solvent, then warming. Ether is the solvent and warming. Then we have to take for hydrolysis in the presence of acid. Sir, what is the product? We'll see. One possibility, 1:2 addition. 1:2 addition means this phenyl ring will be added to this carbon and at this oxygen hydrogen will be added because we are taking for hydrolysis. Okay, so 1,2 addition in the sense at this carbon phenyl ring will be added. This oxygen becomes OH group. Okay, it is 1,2 addition we can say. So at this carbon phenyl group is coming, this O becomes OH, this double bond is there as it is. It is a 1,2 addition product. It is 1,2 addition product we can say. This product is 1,2 addition product. Then we'll see 1,4 addition product. 1,4 addition product in the sense it is fourth atom. At this carbon atom, phenyl group is added. Then at this oxygen atom, hydrogen is added. Then pi bond will be produced at this place. Between these two pi bonds, new pi bond will be produced. This oxygen is OH. This hydrogen comes to this place in the sense pi bond disappears. Sorry. First we will write 1,4 addition product. It is first atom. Here hydrogen we have to add. Second atom, third atom, fourth atom, phenyl we have to add. Then between these two pi bonds we have to remove. Common we have to give. Here pi bond we have to give. That is 1,4 addition product. Okay. So we are writing 1,4 addition product. Here phenyl ring will write. Here pi bond will write. Here OH will write. It is 1,4 addition product. This 1,4 addition product undergoes a keto-enol tautomerism. It is going for tautomerism. Tautomerism in the sense this bond is coming to this place. This bond is going to this place. This C minus taking this H plus. Therefore, we are getting a what product in the sense we are getting so and so product. It is a double bond O, here pH will be there. It is 1,4 addition product. On tautomerism we got this. Okay, it is 1,4 addition product we can say. So 1,4 addition product we got. So we got this acrolein on reaction with the Grignard reagent. We are getting 1,2 addition product and 1,4 addition product. Which is major and which is minor, that we have to see. Which product is major? Which product is minor? That point we have to see. Okay. The major is which one? Shall we say 1,4 addition product, shall we say? Or shall we say 1,2 addition product? Which shall we say? Which is major, shall we say? Okay. Now, 1,2 addition product means here double bond is there. This double bond can go for hyperconjugation with this alpha carbon is having one nitrogen. This double bond is going for hyperconjugation with this alpha carbon having one nitrogen with one alpha hydrogen. Now we will see here. This double bond also is going for hyperconjugation with this carbon. This carbon is having two hydrogens. So this double bond, this pi bond is going for hyperconjugation with this carbon, which is having two alpha hydrogens. These two alpha hydrogens is going for hyperconjugation with this pi bond. Sir, here hyperconjugation possible. Here also hyperconjugation is possible. Next, this pi bond is in conjugation with this lone pair. Therefore, it can go for tautomerism. But this pi bond is not in conjugation with this OH. This pi bond is not in conjugation with this OH oxygen. But this pi bond is in conjugation with this oxygen lone pair. Therefore, it goes for tautomerism and giving ketone. Therefore, out of 1,2 addition and 1,4 addition, 1,4 addition is a major product and 1,2 addition is minor product, we can say. So it is major product, it is minor product. Okay, sir. So we can say that 1,4 addition product is a major and 1,2 addition product is a minor, we can say. Sir, we'll go for next reaction. Next we will take a here so and so we'll take. Here pi bond is present, here methyl group is there. Now we'll take methyl magnesium bromide. Methyl magnesium bromide will take. Ether is a solvent. Warming. Hydrolysis in the presence of acid. Hydrolysis in the presence of acid will take. Okay. So what are the products we will get? That we will see. What are the products we will get? That we will see. One is 1,2 addition product. Another one is 1,4 addition product. Okay. 1,2 addition product means this oxygen we have to take it as first atom. Here H we have to add. It is second atom. Here this methyl we have to add. Okay, it is what in the sense 1 to addition. 1 to addition means like this. So here oxygen becomes OH and methyl we have to add. It is 1 to addition product. Next we will see 1,4 addition. We will see 1,4 addition. This is first atom, hydrogen is coming. Second atom, third atom, fourth atom. At fourth atom, this methyl is coming. Between this pi bond and this pi bond, here we have to give pi bond. These two pi bonds we have to vanish it. Okay, sir. Oxygen becomes OH. We said oxygen becomes OH. Here methyl group comes. Here pi bond we have to give. Okay. It is 1,4 addition product. It goes for tautomerism. It goes for tautomerism. This on tautomerism gives what? Gives what in the sense? This on tautomerism gives this bond comes to this place. This bond goes to this place. Hydrogen comes to this place. Okay. Therefore, we will get a O double bond. Here two methyl groups are present. It is a what in the sense 1,4 addition product. Okay. This 1,4 addition product is major. 1,2 addition product is minor. Okay. 1,4 addition means remember that same carbonyl group you will get. That means this methyl group you added this fourth carbon. Okay. 1,4 addition product last tautomer we want to get in the sense this keto group add it same. Okay. It is first atom, it is second atom, third atom. At fourth atom, this methyl group you add it, pi bond remove it. That is the product. 1,4 addition product. Like this we will remember. Sir. Next reaction we'll see in this 1,2 addition, 1,4 addition continuation. Now we'll take a so and so we are taking here pi bond is present. So and so we have taken. Now we'll take Grignard reagent, ethyl magnesium bromide, ethyl magnesium bromide. Ether is a solvent, warming, and hydrolysis in the presence of acid. Hydrolysis in the presence of acid. Okay. So what we will get? That we'll see. Now we will take a 1,4 addition product. We will take 1,4 addition product means this oxygen becomes OH. It is first atom, second atom, third atom. Between second atom and third atom, pi bond will be produced. At fourth atom, this ethyl group comes. These two pi bonds we have to vanish it out. Okay. So what we are getting, we'll see. Now this O becomes OH. Here pi bond comes. Here ethyl group comes. Here ethyl group comes. Okay. Now we'll take this for tautomerism. We'll take this for tautomerism. One comes here. This one goes here. H plus comes here. H plus comes to this place. So we are getting a here a double bond O. Here it. Therefore, what is this reaction in the sense? It is ester. Here also ester only. It is ester. Here also ester only. But at this carbon, this ethyl group is introduced. That is the difference. Okay. This on 1,4 addition, what is a product in the sense? This functional group ester, no change. Functional group ester, no change. At this carbon, ethyl group is added. At this carbon, ethyl group acid added, pi bond is vanishing. That is the product. Sorry. Next, we will take a so and so. So and so we will take. Now we will take Grignard reagent, ethyl magnesium iodide. We will take solvent is what in the sense ether on warming and hydrolysis. So what we will get here? Now here 1,2 addition we will write. 1,2 addition means at oxygen, this oxygen becomes here hydrogen is added. At this second atom, ethyl is added. Ethyl group is added. So O becomes OH. At this carbon, ethyl group is added. Okay. It is a what product in the sense 1,2 addition product. 1,2 addition product. Then we'll see 1,4 addition product. 1,4 addition means this O becomes OH. It is second atom, third atom. Between second atom and third atom, pi bond comes. At this fourth atom, ethyl group comes. Okay, ethyl group comes at fourth atom. Sorry. So one methyl, another methyl. Here ethyl group. Here pi bond. This O becomes OH. Then this methyl. This is the product we are getting. It is 1,4 addition product. It is a 1,4 addition product, we can say. Now this is major. In this case, 1,2 addition product is major. Why 1,2 addition product is major? Because in 1,4 addition, this carbon becomes a tertiary carbon. This carbon becomes a tertiary. Tertiary in the sense steric hindrance will be more. Tertiary in the sense steric hindrance will be more. Steric hindrance will be more. Okay, it is 1,4 addition. Yes, steric hindrance will be more. Okay, therefore, 1,2 addition is the major product, we can say. Next step. Next step, reaction we'll see. Now we will take one reactant. What is a reactant called? So and so reactant we have taken. I have taken so and so reactant. This is it is not a alpha beta unsaturated carbonyl compound. It is not alpha beta unsaturated carbonyl compound. But what is there means here one carbonyl group is there, one ester group is there. This carbonyl group is electron withdrawing group. This ester contains C double bond O. It is also electron withdrawing group. Now this carbon, this is methylene group CH2. This methylene group is in between these two electron withdrawing groups. Here methylene group present in between two electron withdrawing groups. Okay, like this is present. Now here tautomerism is possible. In this case, what is possible in the sense tautomerism is possible. How tautomerism is possible, that we will see. Here this is methylene group contains H. Now what happens means this bond is going here, this bond is going here, this H plus is going to this oxygen. H plus goes to that oxygen. So what I will get in the sense here pi bond will be produced, this double bond O becomes OH. Here what we can say in the sense a double bond O, here like this we can say. So and so we said it is enol form. It is a double bond in alcohol OL, therefore it is enol. We can call this as a enol. Okay. Now this is called a keto-enol tautomerism. In this resonance, which percentage is more means this percentage is more when compared to this percentage. Why this percentage is more? Generally, ketone will undergo tautomerism. In this keto-enol tautomerism, this enol percentage is more, keto percentage is less. Generally, in the sense ketone percentage will be more, enol percentage will be less. It is a reverse of normal. This percentage is more. That means reverse of normal case. Why? Because here hydrogen bonding is possible. Between this H and this O, hydrogen bonding is possible. Due to hydrogen bonding, we are getting 6-membered ring. Therefore, it is having some stability. Therefore, this enol form percentage is more. So, when in the keto-enol tautomerism, keto group and enol will be in a resonance. Keto group and enol group will be tautomers, isomers. Generally, ketone percentage will be more, enol percentage will be less. But in this case, enol percentage will be more. Why enol percentage is more in the sense here hydrogen bond is produced, therefore 6-membered ring is created. Such a type of situation possible in which case? If methylene group is flanked by 2 electron withdrawing groups, then such a type of case is possible. So when enol percentage is more, that is possible if methylene group, it is CH2, here CH2 is there. This CH2 is flanked by 2 electron withdrawing groups. When methylene group is flanked by 2 electron withdrawing groups, then we can say enol percentage will be more, we can say. Sorry, okay. So we have taken here what in the sense? So and so reactant we have taken, it is in a so and so equilibrium. Okay, so and so equilibrium we can say. To this, let us add Grignard reagent. To this, let us add Grignard reagent. What will happen? Here, if we add Grignard reagent, what happens in the sense? Now, this bond is shifting to this place. This bond is shifting to this place. This O minus will attack this methyl, this magnesium. This Me minus methylide will take this H plus. Okay. This bond is shifting to methyl, therefore methylide. This methylide means CH3 minus. This CH3 minus takes H plus and becomes CH4 and leaves. This Mg plus, this Mg is having positive charge. This positive charge attacks this O minus. Therefore, OMgI it will become OMgI we can say. So it will becomes OMgI. OMgI. Then here double bond O, here O, so and so we are getting. We got so and so. So here it is what is the reaction in the sense enol reacting with the Grignard reagent. Okay. Enolic form reacting with the Grignard reagent in the sense in the enolic form this OH group is having acidic hydrogen. This acidic hydrogen takes a alkylide of Grignard reagent and becomes alkane Then we are getting so and so. Okay. So enolic form with the Grignard reagent reaction is so and so. Okay. So enolic form with the Grignard reagent reaction gives what in the sense alkane is the product. Okay. Next reaction we'll see. We'll take so and so. We have taken so and so. We have taken. Okay. It is a nitro compound. This nitro compound can go for tautomerism. This nitro compound can go for tautomerism. Here this carbon is having two hydrogens. It is going for tautomerism. How this tautomerism will be there, we'll see. This bond is shifting here. This bond is shifting here. This H plus comes to this place. This bond goes to this place. This bond goes to this place. This H plus comes to this place. So we are getting here double bond, here N, here OH, here O minus, here positive charge. We will get to so and so. Okay, we will get so and so. Now, to this, let us add a Grignard reagent. To this, let us add Grignard reagent. To this, let us add Grignard reagent. So what happens? We'll see. This bond is shifting here. It is attacking this H plus. This bond is shifting here. O minus is attacking this Mg. This ethylide, this ethyl group takes this bond and becomes ethylide. Ethylide takes H plus and becomes ethane. Then what is the remaining in the sense? This double bond N plus, this O minus reacts with Mgi and this O minus. So and so product will get. So here you can see that this nitro compound undergoes tautomerism. Therefore, we are getting a nitronic acid. This nitronic acid reacting with the Grignard reagent and giving so and so product. Alkane we are getting. We are getting alkane is the product. So now we will see Grignard reagent reaction with many compounds we have seen so far. So Grignard reagent reacting with many compounds. How the reactivity of Grignard reagent will be there with many functional groups, that we will see. So one is alcohol. Alcohol is having higher reactivity when compared to aldehyde. With what in the sense? With the Grignard reagent. Alcohol goes for higher reaction with the Grignard reagent when compared to aldehyde. What is the reason? That we'll see. We'll take alcohol. We'll take Grignard reagent. We'll take Grignard reagent. What is the reaction takes place here? We'll see. Here this bond is shifting to R. This R is taking H plus. This R is taking H plus. This bond is shifting to O. This O minus is attacking Mg. Therefore, what we are getting in the sense RH and RO MgX. or OMGX. So in the alcohol, the proton is there. In the alcohol, OH group is there. OH group is having acidic hydrogen. In the Grignard reagent, R group abstracting alcoholic H group H and becomes alkane. So the Grignard reagent, in the Grignard reagent, the R group will abstract proton from which, in the sense, from acids. From acids, it will abstract proton and becomes RH. So Grignard reagent can react with even aldehyde. How that reaction will be there, that we'll see. Grignard reagent is reacting with aldehyde. How that reaction will be there, that we'll see. Here, in this case, this bond is shifting to this R. This is attacking this carbonyl carbon. This bond is shifting to this. This magnesium is going to this. Therefore, we are getting RC, R dash, here H. Double bond becomes single bond, OMGX. Now you see, Grignard reagent reacting with alcohol as well as aldehyde. Which reaction is simple and easy? Just here abstracting proton, that's all. But here not like that. It has to be created as nucleophile. Nucleophile has to attack this electrophile. Then only reaction is possible. So that it goes faster when compared to this. Therefore, alcohol is having higher reactivity with then aldehyde. Aldehyde is having higher reactivity with the ketone. Ketone is having higher reactivity with acid halide. This we have seen already. Acid halide. Acid halide is having higher reactivity when compared to ester. Ester is having higher reactivity when compared to anhydride. Anhydride is greater than that of amide. Anhydride is greater than that of amide, greater than alkyl halide. Alkyl halide. Like this reaction will be there. Okay. So next we will go for a aromatic aldehydes and ketones ring substitution. We'll see. Aromatic aldehydes and ketones will go for a ring substitution. Aromatic aldehyde and ketone ring substitution will go. Now we'll take benzaldehyde. We are taking benzaldehyde. It is going for chlorination. Chlorination in the ring, in the sense we have to take halogen carrier. Halogen carrier is FeCl3. CHO is electron withdrawing group. Therefore, it is meta director. Therefore, chlorination is possible at meta position. Chlorination is possible at meta position. Aldehyde group contains C double bond O. Therefore, we can say it is electron withdrawing group. We can say electron withdrawing group means it is deactivating the phenyl ring. It is a meta director for electrophilic substitution. Here, what is the electrophile created in the sense Cl plus? Cl plus is attacking at meta position. Okay. Now we will take ketone. We will take aromatic ketone. We will take. We are taking aromatic ketone COCH3 here phenyl ring. Okay, aromatic ketone we have said. This will take for chlorination in the presence of halogen carrier. Halogen carrier is what in the sense FeCl3. Now CO group, in the ketone CO group is there. That CO group is electron withdrawing group. Therefore, it is deactivating the phenyl ring towards electrophilic substitution. It is directing the electrophile at meta position. So at meta position, chlorination is possible. Here, what is the electrophile generated in the sense Cl plus is the electrophile generated. Okay. Next, nitration we'll see. Nitration in the sense corn nitric acid and corn sulfuric acid is the nitrating agent. Nitrating agent is corn nitric acid and corn sulfuric acid. Electrophile created is nitronium ion NO2 plus. That NO2 plus attacks at meta position. At meta position. Okay. Then we will take this acetophenone. This acetophenone is taken for nitration. So we'll treat acetophenone with a nitrating agent. Nitrating agent is what in the sense corn nitric acid and corn sulfuric acid. We are getting a nitration at which position in the sense at meta position. At meta position we are getting nitration. Here nitronium ion is the electrophile. Nitronium ion formula is NO2 plus, we can say. Then we will take for sulfonation. We will take for sulfonation. We will treat benzaldehyde with corn sulfuric acid. Sulfonation is possible at meta position. At meta position, which group comes in the sense sulfonic acid group comes. Sulfonic acid comes at meta position. Then we'll take here this acetophenone will take for sulfonation. we will treat acetophenone with corn sulfuric acid. Therefore, at a meta position, what comes in the sense sulfonic acid group comes. Sulfonic acid group comes. In this process, in this sulfonation, what is the electrophile in the sense SO3 is the electrophile. SO3 is the electrophile. In the SO3, positive charge will not be there. SO3 is the electrophile. Next, polymerization. Formaldehyde. Formaldehyde on polymerization gives a metaformaldehyde. Formaldehyde on polymerization gives metaformaldehyde. Metaformaldehyde. Another name is trioxane. Trioxane. That formula is what in the sense trioxane formula is a so and so. Trioxane formula is so and so. Next, the formaldehyde undergoes polymerization to give paraformaldehyde. Paraformaldehyde. What is the formula of paraformaldehyde? Means paraformaldehyde is this one. It is a paraformaldehyde. So formaldehyde on polymerization gives in one case metaformaldehyde, another case paraformaldehyde. Next we will take acetaldehyde. Will take this acetaldehyde in the presence of acid at 298 Kelvin. In the presence of acid at 298 Kelvin gives a polymer. The polymer is what in the sense paraldehyde. Paraldehyde is a polymer. That paraldehyde formula is so and so. So we are getting the paraldehyde like this. So and so paraldehyde is possible. This paraldehyde we can use it as a hypnotic substance. This paraldehyde we can use it as a hypnotic substance. Okay. Now how to get to this paraldehyde? That point we will see. Now acetaldehyde we will write it as CH3, CH double bond O. We have written. Next acetaldehyde we are writing like this. Next acetaldehyde we are writing like this. We have written like this. So how the bond shift takes place, we will see this pi bond shift in between this oxygen and carbon. This pi bond shift in between oxygen and carbon. This pi bond shift in between oxygen and carbon. We will get this. Okay, we will get to this paraldehyde. We will get. We are getting this paraldehyde. Okay. Next, acetaldehyde in the presence of acid at 273 Kelvin. Acetaldehyde in the presence of acid at 273 Kelvin. What we will get in the sense metaldehyde we will get. We are getting what in the sense metaldehyde we are getting here. We are getting a metaldehyde. Here how we got paraldehyde? In the previous case we got paraldehyde by taking 3 acetaldehyde. Now we are getting metaldehyde by taking 4 acetaldehyde. Okay. Next. We'll see metaformaldehyde and paraformaldehyde will take. Here we got metaformaldehyde and paraformaldehyde. This on heating gives back formaldehyde. This also on heating gives back formaldehyde. This paraformaldehyde on heating gives back formaldehyde. Metaformaldehyde or trioxane on heating gives back formaldehyde. Okay. Next. Next we will see this paraldehyde and metaldehyde. Will see this on treating with the dilute sulfuric acid gives back acetaldehyde. Gives back acetaldehyde. Then this metaldehyde on treating with the dilute sulfuric acid gives back acetaldehyde. Gives back acetaldehyde. Okay. Now we will see this is about a polymerization of aldehyde. Next we will see polymerization of ketone. We will see. Now we will take a acetone. We will take acetone. We are taking. This is going for polymerization in the presence of dry HCl. In the presence of dry HCl. What product we will get that we will see. Here the product is CH3C, CH3, double bond CH, CO, CH3. This is the product we are getting. This product name is what in the sense? Mesityle oxide. This product name is mesityle oxide. How this product is obtained at that point we will see. Now we will take acetone. We are taking acetone. Next, another time acetone will take. Another time acetone we are taking. So here what is eliminated in the sense? Like this, water is eliminated. Therefore, we are getting this mesityle oxide. This mesityle oxide we got. Next reaction we'll see. Acetone in the presence of corn sulfuric acid, gives mesitylene. Mesitylene we can say. How we are getting this mesitylene? That point we'll see. How we are getting this mesitylene? Now, acetone 1CH3, it is C double bond O. Here CH3. Here CH3 we have written. Now, we will take another acetone. In another acetone, H2, CH2, CH3, C double bond O, CH3. Next, another acetone will take H2H, H2CH, C double bond O, CH3 we have to write. C double bond O, CH3. Okay. Now this C double bond O, we will write it as like this, and CH3 we are writing. Set. Now we will round up. Here water we have rounded up. Here we rounded up water. Here we rounded up water. It is this will make it as 2. Here we will made it round up 2. This water will make it. Water we are removed. So what we are getting in the sense, we will get this mesitylene. We'll get what in the sense mesitylene we will get it. Okay. So we are getting a mesitylene is the product. Therefore, acetone with corn sulfuric acid we are getting mesitylene. Acetone with dry HCl gas. Acetone with dry HCl gas gives what in the sense mesityle oxide. Another possibility is there with the dry HCl. Now we will see another possibility with the dry HCl. With the dry HCl, another possibility is what in the sense so and so. Here another possibility like this. Okay, this acetone with a dry HCl. With a dry HCl, another possibility is like this. This is called a poron. This is called poron. How to get this poron? We'll see. This one acetone. It is one acetone. This one acetone. Now we'll write CH3 like this. CH3 we have written. Another acetone will write O double bond C CH3 CH3. Let us round off